Okay, here I'm going to do a slow motion kinematics problem. When I say slow motion, I don't mean that the kinematics are slow motion. I mean that I'm going to go through it really slow. Okay, so the kinematics problems, they always start by giving you a velocity function. So here is our velocity function for this problem. And remember that this is not complicated if you follow the steps that they give you. And I don't think you guys are too much for thinking of your own mnemonic, so I'm going to give you my mnemonic, and if you choose to use it, great. If you think it's dumb, then you just think of your own mnemonic, which is probably going to be better. Okay? So my mnemonic is called SISMO. SISMO because the first step is to take the sign diagram. And the second step is to integrate. And the third step is to find S of t for the end points and for the critical points. And last of all, you make a motion diagram. Okay? So those are the steps to doing any of these kinematics problems. So as long as you follow the steps, these problems are kind of not typical IB problems because they're just basically can you remember the procedure? Alright. So we have this velocity function, and what they're going to ask us is, find the total distance traveled from t equals 0 to t equals 0 to 2, and I did use x here. I'm sorry about that. I should have put t. So it should be 2t squared minus 7t plus 3. Why t? Because t is the x variable in this case, but t is usually used when we want to say time, and so we want to say, how far does the particle or car or whatever travel from x equals 0 to 2, the complicated thing being that the velocity is going positive, it's going negative sometimes, and you cannot simply take the integral because then the positive parts are going to cancel the negative parts. Okay, so you need to divide it into sections. So that, if you were doing this with a calculator, it wouldn't be so bad. You could just graph it. And then you could use it do it like a typical area integration problem. You would say, there's this part that's positive, there's this part that's negative. I'm going to break it up into pieces. I'm going to integrate it separately, etc. But with these kinematics problems, sometimes you don't have the calculator, and maybe it's going to take you more time to graph it. And there's not really any reason to graph it because the only thing you really need to know is which parts are positive, which parts are negative, where are the critical points, where does the velocity cross the the x-axis and become negative when it was positive for, etc. So if you follow this procedure, it's not necessary to graph it. Okay? So first of all, we're going to do the sign diagram for the velocity function. So let's see. To do the sign diagram for this velocity function, we are going to find when it's equal to 0. And you could use quadratic formula or other means, but you could use a calculator if it's the calculator portion of the test. In this case, since it's a non-calculator portion of the test, you can actually factor this. Something like this. Let's try that. Because what did I do? I know that the first side of the binomial is going to be 2t and t. And I know the second side is going to be 1 and 3 because those are the only whole number factors. And if this is the non-calculated portion of the test, I don't think they're going to give us decimal factors. And let's see if this works out. So 2t times t is obviously t squared. Negative 3 times negative 1 is obviously positive 3. Now if I multiply these two together and multiply these two together, negative 2t minus 3t, which is negative 5t. Oops, I was looking for negative 7t. So let's switch these last two. Instead of 3, 1, I'm going to put 1, 3. Now what am I going to get? Now I'm going to get negative 6t minus t. Hey, that's right, it's negative 7t. Okay? So that gave me the right middle coefficient. So I have found my factors. Now, how does this help me find the sign diagram? because if I find 2t minus 1 equals 0, find the root for that, t minus 3 equals 0, find the root for that, that'll give me the points where the sign diagram is 0. So this is going to be 2t equals 1, t equals 1/2, t minus 3 equals 0, t equals 3. So these are the two critical points where the velocity is 0. So if we were going to do the sign diagram, we would write it out. We would write this is t, and it's 1/2 and 3 are the critical points. They're 0 at both these places. Now we're going to say what's the sign of vt at each point. Let's see, at t equals 0, vt would be, and it's useful to use this this form to calculate it because it makes it easier to figure out the signs without doing the multiplication all out. So we'll put in, for example, 0 here. So then we have -1 times -3. It's positive 3. It's a positive number here. What if we put a really big number like 10? Then we'd have 20-something times 10-something, big positive number. And then in the middle, we'll put a number like maybe 2, and then we'll get 4 minus 1, which is positive 3, and then we'll get -1, so it's a negative number, so in between it's negative there. Okay, so there's our sign diagram. That was the first step. Next step, integrate. So now we're going to integrate our velocity function, which is that, and then we're going to get the s of t function. Okay, so s of t is equal to the velocity function integrated, and we're just doing a indefinite integral or an antiderivative, and we're going to get 2t cubed divided by 3 minus 7t squared divided by 2 plus 3t. Okay, and in this case, we don't really need to figure out the integration constant, because whatever the integration constant is, it's not relevant in the total distance traveled between 0 and 2 or whatever. Because if you start plus 2 to the right, you're still going to end plus 2 to the right. In the end, the distance traveled is not affected by your initial position. Okay, so that's why in these problems it's not really important to think about the integration constant. If you want to, you could say that s of 0 is 0 and put in t equals 0 and see if you get 0 out. If you don't, you could put in a different integration constant, but it doesn't matter. Okay, so we found the s of t, and now we need to actually find at least 3 values of s of t, and those are the initial value, s of 0. We need to find the final value, which is going to be s of 2. These are the endpoints, right? And then finally, you'll need any direction changes. And the direction changes are at s equals 0.5, or 1/2, right? And the other direction change is at 3. Now, 3 is after the endpoint of 2, so we do not really need to figure out the s of 3 because it's after the problem has ended. Okay, so let's not figure that one out, save ourselves a little bit of trouble. S of 0, you can see that if you plug in s of 0 or t of 0, we're going to get just 0. What if we plug in t equals 2? Okay, then we're going to get something a little bit more complicated. We're going to get 2 times 2 cubed, which is 8, 2 times 8, which is 16 divided by 3. Then we're going to have, we're going to put t equals 2, and we're going to get 4, 7 times 4 is 28, divided by 2 is 14. And then we're going to have 3 times 2, which is 6. Okay, so basically here we have 16 thirds minus 8. And so that, if we put the common denominator of 3, we're going to have negative 24 thirds plus 16 thirds. It's going to be negative 8 thirds. Okay. What about s of 0.5? Okay, so if we put 0.5 in here, we're going to have 2 times 1/8 over 3 minus 7 times 1/4 over 2 plus 3/2. That's awful, isn't it? So 2 over 8 is 1/4, divided by 3 is 1/12. 7 over 4 divided by 2 is 7/8. 3 halves is 3 halves. And now if you were going to put that over a common denominator, let's see, the common denominator would be 3 times 4 times 2, it's 24. So it's going to be, if this was 24, this one would be 2. If this was 24, this would be 21. If this was 24, this would be 36. So 36 plus 2 is 38, minus 21 is, it's like 17, I think. Is that right? 36 plus 2 is 38, minus 21 is 17. Okay, so the S of 0.5 is 17/24. S of 2 is negative 8/3, and S of 0 is 0. Okay, so now we've done the integrate, and we've done the S of t. The only thing left is the motion diagram. Okay, so the motion diagram, let's assume that the motion starts at s equals 0, and we know that the initial velocity at s equals 0, the velocity is positive, so it's going to the right. When does it actually turn around? Well, it turns around at s of 0.5, which is 17/24, right? It turns around, and the t happens to be t equals 1/2, right? And then turns around. And then where does it end up? It doesn't have any more direction changes, and it ends up at negative 8/3, right? S of 2 is negative 8/3. So this happens at t equals 2. Okay, so now to figure out the distance traveled, it's just a simple matter of calculating, doubling that distance, and then adding this distance here. So the green distance is 17/24. And since we have it twice, we just multiply it times 2. And then the orange distance is 8/3. And even though it's going to negative 8/3, we'll just consider it a positive quantity because we just want the total distance, right? So now we're going to have 17/12 plus 8/3. And once again, we're going to do some complicated fractions here. So we're going to put this over 4, and we're going to multiply. Times 4 is going to be 12. 3 times 4 is 12. And 4 times 8 is 32. So we have 32 plus 17, 49 divided by 12. So the total distance traveled in this case, that's going to be 49/12, right? 2 greens plus an orange. So all you need to do, remember, is to follow this procedure. SysMo, the sign diagram, then do the integration. You don't need to do the integration constant. Find the S of t values for the endpoints and for any direction change points. And then you do a motion diagram, and then it becomes obvious what the distance traveled is.